Hey there. Welcome to our channel. We're so glad you're here. Please like, share, and subscribe to join us for awesome content. Also share this video with your family and friends. Let's get started. The gentle expansion. There is a hush in the darkness above you. A silence that stretches wider than thought. You let go, and your body becomes weightless. A speck released from the grip of Earth's hands. Here, in this quiet nowhere, you begin to notice something strange. The stars are not still. They move, not like birds in a flock, but like faraway lanterns drifting from one another, slowly, endlessly, as though space itself is gently exhaling. You hover in this slow tide of light and feel it in your bones. This pull that is not a pull, a movement not caused by wind or will. You are inside the breath of the cosmos, and with every passing moment, the universe grows just a little larger. Once this was a shocking idea. For a long time, people believed the universe was static. A grand, celestial still life. Galaxies fixed, stars eternal. A cosmic dome unmoving in the heavens. But then came a discovery, quiet and world-shifting. Astronomers, peering into space, saw something unexpected. The light from distant galaxies was stretched. Not in color, but in journey, a kind of redness in the light that meant those galaxies were moving away. Not just some of them, all of them. Wherever you looked, things were drifting apart. Not falling, not fleeing, but expanding. You imagine a raisin in dough, baking slowly in a warm oven. As the dough rises, every raisin moves away from the others, not because the raisins are running, but because the space between them is growing. Galaxies, too, are like this. Bound in their own clusters, but slowly pulling away from one another, carried by the stretching fabric of space. You reach out in your mind and feel the thread of it. Not gravity. Gravity pulls things together. This is its opposite. A soft push outward, a swelling between stars. The universe, it turns out, is not just expanding. It's expanding faster than ever before. You float through this idea like drifting through fog. What makes the universe swell faster with time? What is this force that opposes gravity's embrace? We call it dark energy. But that name is a placeholder, a soft silence. We do not yet know what it is, only that it's there, shaping the large-scale fate of everything. Dark energy does not clump like matter. It does not glow or weigh. It simply behaves, a quiet rhythm in the background, making space itself grow like ripples from a hidden drum. You look back toward the Milky Way, its spiral arms curling like a sleeping fern. Even your own galaxy is not immune. It, too, is part of this grand expansion, though bound for now by the invisible threads of gravity to its nearest neighbors. Yet the space between faraway galaxies, it stretches endlessly. And so, if you wait long enough, whole galaxies will vanish from view, not because they end, but because their light can no longer catch up. The space between you and them grows too fast. The distance outpaces even light. You close your eyes and imagine. A time when only the closest stars remain visible. A sky that grows darker not from nightfall, but from the fading away of light itself. This is not a threat. It is a truth, one told in the language of soft motion, in the arithmetic of emptiness. The expansion is not violent. It is not something you feel on your skin. It does not tug at your heart or swirl your thoughts, but it shapes everything. It decides what will meet, what will drift, what will be possible in a billion years. In the background of existence, there is a kind of music, and dark energy plays the slow, sustained notes, notes that lengthen time, that stretch the score. You listen now, not for sound, but for presence. The expansion is like a breath that never ends, a sigh stitched into space itself. And like breath, it changes everything, quietly, patiently, without asking for permission. You imagine yourself not as a person, but as a particle of space itself, something small caught in the flow of an ever-widening sea. How far will it go? Will it stretch forever? Or will it slow, like a wave reaching its end, falling back in on itself one day? That thought waits quietly ahead. For now, you drift inside the gentle expansion, wrapped in the hush of distance, held in the widening cradle of all that is. And in the distance, a flicker, a supernova, A quiet clue that something far away is moving differently than expected. The discovery in the flicker ***. You drift now toward a distant light, a single point glowing softly in the dark. It pulses like a memory, bright and slow, a candle in the deep sea of space. This is a type Ia supernova, a star's final breath, brief and brilliant. A white dwarf pulls too much matter from a companion star, and when it cannot hold its weight, it collapses and erupts, sending out a perfectly bright flare like a lighthouse at the edge of existence. Astronomers love these explosions. They are predictable, always reaching the same peak brightness. They serve as cosmic measuring sticks. By comparing how bright they look to how bright they should be, you can tell how far away they are. You hover beside one now, not in danger, but in awe. Its light rushes past you, its message written in a long journey across space. And in that journey, there is something strange. When scientists first studied these distant supernovae, they expected them to look a little dim. After all, they were very far away. But the light was too dim, fainter than it had any reason to be. That faintness wasn't a mistake. It was a signal. You think of a car's horn changing pitch as it passes, a Doppler shift. Now imagine light doing the same. If the source is moving away, the light's waves stretch, its color shifts toward red. We call this redshift. The light from these supernovae was not only redshifted, it was more redshifted than the universe's age should allow. This meant the galaxies holding these supernovae weren't just far away. They were speeding away, faster than anyone had imagined. And so came the quiet, unsettling truth. The universe's expansion was not slowing down with time, as gravity might suggest. It was speeding up. You float through that realization now, as if it just arrived in your own mind. The universe is not coasting. It is accelerating. Something invisible, something subtle, is pulling galaxies apart more and more with time. You look down at Earth, a distant speck now, and imagine the moment in the 1990s when two separate teams of astronomers peered through their telescopes, ran their numbers, checked their doubts, and saw the same impossible pattern. The universe was stretching faster and faster. No known force could explain it. This was something new, something that acted not on stars or planets, but on space itself. They named it dark energy, not because it was dark, but because it was unknown. An energy without origin, without interaction, except in how it shapes everything. You feel it now, not as a force against your body, but as a mood in the cosmos. It doesn't push like wind or fall like rain. It is the slow, ceaseless whisper that makes space grow. And it was found not through collision or capture, but through light that traveled for billions of years from stars that no longer exist, flickering just slightly fainter than expected. Imagine walking through a vast hallway, lined with candles. If every candle burns the same, you can tell how far you've walked by how dim the flame appears. Now imagine the last candles seem much dimmer than they should, as if the hallway had stretched while you walked, as if the space between you and them grew longer than it was when they were lit. This is the trick space plays when it expands faster than light can catch up. The signal fades not because it weakens, but because the path becomes longer with time. You follow that lengthening trail now, from one supernova to the next, from observation to inference, from flicker to theory. Each light is a clue, each one a puzzle piece that tells the story of the universe's true pace. And beneath that story, another question begins to stir. What is this dark energy made of? Is it something in the fabric of space? A property of vacuum itself? Or something deeper, stranger? A field we've yet to see? You do not rush toward an answer. Instead, you sit in the question. You breathe with the universe, letting it unfold without needing to grasp it fully. Because what matters, in this moment, is the beauty of discovery. That even in the quiet flicker of a dying star, there is a message about forever. You turn back to that first faint supernova, its light still stretching toward you. A messenger from a time when galaxies were closer, when the universe was younger and more compact. And you understand something else now. This discovery was not just about distance. It was about fate. If the expansion is speeding up, then where does it lead? What kind of future does dark energy create? And how does a force with no mass, no form, no scent or sound, shape the destiny of everything? You close your eyes and float with that question. The light still flickers, space still swells, and dark energy still waits, just out of reach, shaping the way forward in silence. But before we move forward, we must pause and feel what dark energy truly is. Not in the sky, but in the spaces between. What dark energy feels like ****, you float now in silence. Not the silence of emptiness, but the quiet of something too soft to grasp. You try to feel dark energy, to sense it as a warmth or wind, but there is nothing like that. It leaves no ripple, no shadow, no breath. And yet it is everywhere. It doesn't tug at your body or shift the orbit of your thoughts. It doesn't pulse or glow. But it is woven into the shape of space itself. If you could run your fingers along the edges of the universe, you might feel how it stretches, not from force, but from preference. The universe prefers distance. It chooses expansion like a flower chooses light. Dark energy is not an object. It is a kind of behavior, a mood in the fabric of reality. A soft refusal to stay still. You imagine space as a vast, stretching cloth, and every thread is slowly being pulled. Not from the edges, but from within, each point moving away from every other, not pushed by something outside, but carried by the gentle self-expansion of space. This too is dark energy. It does not act like matter. Matter clumps. It gathers into stars, planets, clouds. Dark energy does the opposite. It smooths, stretches, thins. It behaves as if every patch of space wants to become more space. As if emptiness itself is not passive, but gently active, always tending toward more. You try to picture it, but dark energy refuses image. So instead, you feel it through metaphor. It is the pause between breaths, made longer with each inhale. It is the moment between ripples, widening even as the pond stays calm. It is the tilt of the scale toward more room, more quiet, more drift. You are not separate from it. Your body, your atoms, your thoughts exist inside this stretch. Your cells carry the expansion like dust on a wind, unfelt, yet ever-present. If you look deep into the spaces between galaxies, you'll find not emptiness, but energy. A low, persistent energy that does not vanish as space grows. In fact, it stays constant, so as space expands, more of it appears. More space means more dark energy, which means faster expansion, which means even more space. And so the loop continues, a gentle feedback written into the bones of the cosmos. You drift farther from the galaxies now, into the thin threads between clusters. These voids are not truly empty, they are soaked in this stretching tendency. You listen with your thoughts. Not for sound, but for motion, the slow, accelerating hum of space giving birth to more space. And you begin to realize, dark energy is not a presence. It is a rhythm, pace, a decision the universe seems to make again and again to grow. Where did this rhythm come from? Was it always there? Did it awaken when the universe cooled? Or has it pulsed since the first instant? We do not know. You think of the early universe, hot, dense, wild with light. Back then, dark energy was barely noticeable. Gravity ruled. Matter crowded together into stars and galaxies. But as space grew, and the matter thinned, dark energy began to speak louder. Its influence grew not by force, but by scale. The emptier the universe became, the more this quiet energy filled the silence. Not to dominate, but to stretch. It does not fight gravity directly. It simply waits, expanding the stage on which gravity acts, widening the scene until gravity's pull grows faint. You drift through this balance, feeling how gravity pulls in, and dark energy lets go. One binds, the other releases. They do not hate each other. They are not opposites. They are two tendencies, one to gather, one to spread. And we are caught in between. Our galaxies, stars, planets, they are still close enough for gravity to hold them together. But on the scale of the universe, dark energy has taken the lead. The cosmic dance has changed tempo. You close your eyes and feel it more deeply now, not as a theory, but as presence. You imagine your thoughts stretching like space, each one softly floating away from the last. Your breath slows, your limbs lighten, and you drift into the feeling of distance becoming normal. This is what dark energy feels like. Not a push, not a pull, but a drift. A choice to let things move apart. And you wonder, if this energy has no edges, no beginning, no limit, then where does it take us? Where is the universe headed? Carried not by stars or wills, but by this invisible lean toward openness. To glimpse that future, you must look ahead, into the long silence, into the cooling dark, where the expansion never stops, where everything in time drifts beyond reach. Gravity's old reign ends quietly ****. You drift through a time before expansion ruled, when gravity reigned with quiet strength. It was the architect of everything you know, the sculptor of stars, the weaver of galaxies, the steady hand that drew matter inward, again and again until light was born. Gravity is not loud. It does not strike or shout. It is patient. It waits. It accumulates. You float through the earliest moments after the Big Bang. The universe was dense, hot, and young, filled with particles racing and colliding, seeking balance. Out of that fire came structure. Atoms formed, then stars, then galaxies, swarms of light gathering in the slow pull of gravity's embrace. Imagine space as a great still pond. Every drop of matter creates a small indentation, a dip in the surface. Other matter rolls into that dip, drawn not by touch, but by the shape of space itself. This was how gravity ruled, not by command, but by suggestion. It held galaxies together like a hand holds sand, pulled gas into stars, stars into clusters, clusters into walls of matter stretching across the sky. For billions of years, gravity shaped the visible universe. You see its fingerprints in every spiral, every orbit, every ring around every planet. You were raised in this gravity-ruled world. Your body formed under its pull. You walk, sleep, breathe beneath its constant guidance. Even as you float here in this imagined stillness, you carry the memory of falling. But something has shifted. You turn your gaze to the scale of the universe itself. Zoom out far beyond stars and galaxies. There, in the great between, you begin to feel gravity weaken, not by flaw but by vastness. Gravity fades with distance. The strength stretches thin. And on the grandest scales, it loses its grip. You've already felt what takes its place. Dark energy, that persistent pressure, not strong but everywhere. It does not wrestle with gravity. It simply waits until gravity becomes quiet enough to be outpaced. You imagine a long tug of war. At first, gravity pulls harder, drawing matter together, slowing the expansion. The universe decelerates. But over time, as galaxies move farther apart, the effect of gravity softens. The rope grows slack. Dark energy takes hold, gently at first, then unmistakably. You are floating in that turning point. The moment the universe flipped from slowing down to speeding up. It happened around 5 billion years ago, a subtle shift in cosmic balance. The expansion no longer resisted gravity. It slipped beyond it. Dark energy began to lead. You travel now through a deep cosmic future. Galaxies retreat from one another, and the space between them thickens like cooled glass. Clusters grow isolated. Star-forming gas thins and fades. Gravity tries to hold its scattered structures together, and in small pockets it succeeds. Galaxies remain intact, for now. Stars continue to orbit, for now. But beyond those neighborhoods, the universe grows quiet and separate. Imagine two galaxies, once neighbors, now drifting apart at ever-growing speed. No message, no photon, no light speed signal can bridge the widening gap. Even light, the fastest thing we know, is outpaced by the expansion. You float between them, feeling the stillness of loss. Not dramatic, but slow. A farewell stretched across eons. This is how gravity's reign ends, not with a clash, but with distance. And still, gravity has not vanished. Within galaxies, it remains the sculptor. It holds stars in their spirals. It binds moons to planets, and planets to suns. In your own body, gravity continues to speak in the language of weight and ground. But on the grandest scales, it has become a memory, an echo of closeness in a universe that chooses distance. You imagine what this means not just for structure, but for time. The future stretches long and dim. Galaxies grow lonely. New stars become rare. Eventually, only red embers remain. Cool, faint, slow-burning remnants of a time when gravity gathered the night into fire. You pause in that long future. No collapse, no explosion. Just fading. And then you wonder, must it be this way? Is this ever-accelerating expansion our destiny? Or could it change again? Subtly, silently, the way it once did before? Could gravity reclaim its reign if dark energy were to shift, weaken, or end? You turn toward that question like one might turn toward a whisper in a dream, not to answer but to follow. Because if dark energy can grow stronger with time, might it also fade? Might this acceleration be temporary? And if so, what then? The constant that wasn't ***, you drift now through an older sky. Not the sky of stars, but the sky of thought. The universe once lived only in minds. Before telescopes, before equations, it was imagined in silence. You find yourself beside a quiet desk, papers scattered, ink drying. A man bends over his calculations, his thoughts orbiting the deepest questions of time, space, and motion. This is Einstein. His pen moves slowly. He is trying to understand everything. And in doing so, he is drawing the shape of the cosmos with numbers. In 1915, Einstein gives us general relativity, a theory of gravity not as a force but as a bending of space and time. Mass tells space how to curve. Curved space tells matter how to move. It is a beautiful theory, and it works. But then something bothers him. When he applies his equations to the universe as a whole, they suggest it must be expanding or contracting, not sitting still. At the time, this seems wrong. Everyone believes the universe is eternal and static. So Einstein tweaks his own equations, adding a term to cancel the motion. He calls it the cosmological constant, a small term, a mathematical patch, just enough to hold the universe in place. You float beside the symbol now, a Greek letter, lambda, simple, elegant, and uncertain. Stands for something, but no one quite knows what. For Einstein, it is a balancing act. Not a discovery, but a necessity, a stillness folded into motion. Years later, when Edwin Hubble discovers the universe is indeed expanding, Einstein removes the constant. He calls it his greatest blunder. He didn't need it after all, or so he thought. You drift forward now, past decades of discovery, past galaxies and measurements, into the late 20th century, when astronomers look again at the way light moves through space. And the constant returns. Not because someone missed it, but because something in the universe demands it. The expansion isn't just happening, it's accelerating. And the best way to explain it? A small term in the equations of gravity, just like the one Einstein once added. Loving this? Hit that subscribe button to keep up with our videos. Also share this video with your family and friends, a cosmological constant. But this time, not to hold the universe still, to make it speed up. You feel the symmetry of it now, the elegance of how a discarded idea becomes necessary again. It is as if the universe has whispered back through time. Keep it. You'll need it later. You linger beside that constant. What is it, truly? A number. Pressure. A quiet insistence built into the bones of space. It behaves like an energy that exists even in emptiness. Even when there are no particles, no light, no motion, the vacuum still hums. We call this vacuum energy, the restless stillness of what seems empty. In quantum physics, even nothing is not truly nothing. Particles flicker in and out of existence. Fields pulse and vanish. The vacuum is a restless sea beneath the surface of all things. And perhaps the cosmological constant is the whisper of that sea. A leftover breath from the way the universe began. You imagine it as a background rhythm, a hum that never stops. It does not pull or push in the way gravity does. It simply is, spreading space gently outward, like a soft exhale woven into space-time itself. And now, scientists ask, is the constant truly constant? You pause at the question, feeling how even a fixed idea can soften with time. What if the cosmological constant is not a number carved in stone, but a behavior in flux? What if dark energy changes as the universe evolves? Could it grow stronger? Could it fade away? You return your gaze to Einstein's equations, those curves of logic, those loops of thought. They contain beauty, but they also contain mystery. We know how the constant behaves now, but we do not know why it exists or what set its value. And so you drift again, this time not in space, but in possibility. What if the constant isn't constant at all? What if it is just one version of a deeper truth? You follow that thought into models of shifting fields, into whispers of something dynamic lurking behind the math. Because if dark energy is not fixed, then the future is not fixed. And neither is fate. What was once a blunder may be a clue. What was once a constant may be a variable in disguise. And if so, then perhaps we are not just drifting outward. Perhaps we are waiting for the next change in rhythm. Measuring the invisible asterisk, you enter a different silence now. Not the silence of space, but the quiet hum of searching. Around you, the earth spins slowly, blue and alive, while just beyond, machines stretch out their sensors into the dark. You drift past observatories on mountaintops, domes opening like petals to the stars. Within them, mirrors curve like still water, catching ancient photons, messages from far away. You float alongside a satellite quietly orbiting the Earth. It does not sleep. It gathers the faintest whispers, shadows of distant galaxies. The subtle shift of light as the universe continues its slow expansion. These are the tools of our listening. This is how we measure what we cannot see. Dark energy leaves no trail in a lab. It does not curve under gravity, does not bounce off matter, does not flash or flicker. It's not an object, but an influence, something woven into the frame on which reality is stretched. And yet, we know it's there because we see what it does. You hover beside a map of the universe, each dot a galaxy, each cluster a signpost. Some lie far, their light redshifted and slow. Some are near, glowing with younger energy. The pattern tells a story. Space is growing faster. The distances do not match what gravity alone would suggest. So we measure what we can: light, time, motion, silence. We triangulate expansion through 1,000 methods, each one a fragile ladder built from light and guesswork. You trace the curve of a supernova's fading light, a type Ia again, just like those that first revealed the universe's acceleration. You watch as its brightness dims across the sky, not from distance alone, but from the stretching of space itself. Astronomers call them standard candles, cosmic lighthouses with known power, letting us judge distance by how faint they seem. Next, you drift to a different measurement: baryon acoustic oscillations, a long name for a gentle rhythm. Tiny ripples in the early universe, frozen in the distribution of galaxies. These ripples act like rulers. They tell us how matter clumped in those first moments after the Big Bang. By comparing how far the ripples have spread, we track how fast space has expanded since. Another method comes: gravitational lensing. You float near a galaxy cluster, so massive its gravity bends light. A distant galaxy's image stretches around it, twisted into arcs, like light around the edge of a raindrop. By measuring this distortion, we glimpse how matter, seen and unseen, is shaped by the stretching of space. Every method different, every signal delicate. Together, they paint a single message. The expansion is speeding up, and something invisible is responsible. Still, there are questions. You hover beside the Planck satellite, which mapped the cosmic microwave background, the afterglow of the Big Bang. Its data shows the early conditions of the universe in exquisite detail. Tiny temperature shifts, variations in density, the echoes of the first moments of time. From these, scientists inferred how the universe should evolve, and how much dark energy must exist to match what we see now. The numbers align, not perfectly, but closely enough to say something is truly there. Yet still, we cannot hold it. We cannot bottle it. We cannot say, this is what dark energy is. We measure around it. We draw its shadow. We guess its nature by what it makes impossible. And in that guessing, we wonder, is it truly constant, as Einstein's lambda suggests? Or is it shifting, flickering faintly across time, like a candle behind frosted glass? You drift now into a simulation, not in space but in thought. Here, scientists run models of possible universes. Some have a fixed dark energy. Some have a changing one. Some lead to cold stillness, others to violent expansion. Some end in a slow reversal, the fabric of space folding in again like a breath returning home. Each possibility speaks through numbers, equations, sky maps. Each one whispers a different future, but all begin with the same invisible presence. You look again at Earth, spinning beneath you, a world that knows how to question, how to reach through uncertainty with open hands. The effort to understand dark energy is not just scientific. It is emotional. It is the ache of mystery felt in the bones of being human. Because we are part of the universe, and what it becomes includes us. You hover beside the instruments, the telescopes, the sensors, the notebooks filled with equations. You feel the reverence in the search, not for control but for knowing. Not to harness dark energy, but to sit beside it in the great library of space, and turn the page. And now the question shifts. If we can measure the influence, might we one day touch the cause? If dark energy is not a constant, then what changes it? And if it can change, what might it become? A cold, lonely future ***. You drift forward now. Not just through space, but through time. The stars behind you fade softly, their light stretched and thinned as the universe carries you ahead into its own unfolding. This is not a journey of speed, but of patience. You do not race toward the future. You float there, guided by the long, slow breath of cosmic expansion. The present is warm with starlight. Galaxies hum with birth and death. Stars ignite, live for ages and dissolve into dust. Even now, stars are being born in clouds of gas like whispers solidifying into flame. But in the distance ahead, you feel something change. The stars grow fewer. The gas grows thinner. The night deepens. Dark energy continues its quiet work. It does not pause. It does not tire. It simply stretches space, moment by moment, further and further apart. Galaxies that were once neighbors become strangers. Their light no longer reaches one another. They vanish from each other's skies. You watch this happening, slow but relentless. The Milky Way and its local companions remain bound together by gravity, but all others drift away. Soon, only darkness surrounds them. This is the cosmic horizon, the edge beyond which light can no longer return. Not because it isn't moving fast enough, but because the space in between is expanding too quickly. You pass through that threshold now, feeling the stillness on the other side. The galaxies are gone. Their light, stretched thin by time, has faded beyond visibility. It's not that they ended. It's that you can no longer know them. The universe has made privacy its final law. You continue on. Now, trillions of years have passed. Star formation has ceased. The gas that once fed new stars is used up or lost to the dark. What remains are the long-lived stars, the red dwarfs, small and slow-burning, holding onto their glow like embers curled in their palms. Even they will eventually fade. No new stars will take their place. The universe is growing quiet. You drift among the remnants. White dwarfs cooling to black, neutron stars spinning more slowly, black holes swallowing the last of what falls near. There is no drama here. No explosion, no chaos. Just a slow unmaking, fading not into fire, but into space. Time continues. So does expansion. The galaxies that remain are frozen islands, drifting ever apart in a sea without current. You float through one, an old galaxy, its stars dim and dying. It does not know it's alone. It simply is. The space between atoms remains tight. Gravity still holds planets to stars, stars to remnants, for now. But in the great beyond, everything stretches. Eventually, black holes themselves will fade. Not violently, but gently, through Hawking radiation, a slow leak of existence into the void. You watch one now, a vast black hole, the silent heart of a long-gone galaxy. It flickers once, then once again. Its mass slips away over quadrillions of years until it is no more. And then only particles remain, some still, some racing. A low fog of matter in a cold and widening space. This is the heat death, a misleading name for there is no fire. It is not a death of burning, but of balance. The universe has reached thermodynamic equilibrium. There is no more usable energy. No gradients, no flow, only stillness, only cold. The universe has not ended, but it has ceased becoming. You pause here, in this vast, empty future, and listen. There is no sound, no new stars, no new light, just particles drifting in a space too large to notice them. And yet, in this quiet, there is wonder. Because all of this, the stars, the galaxies, the black holes, the silence, was written into the first moments of the universe. Dark energy's quiet insistence was always part of the song. It's easy to think of this as tragic, the fading, the cold, the distance. But you could also think of it as peaceful. A slow return to stillness after a lifetime of fire. Not an ending, but a long, soft exhale. You imagine the last photon crossing the void, unseen, unchanged, still moving through the skeleton of time. And you wonder, is this truly the final chapter? What if dark energy is not forever? What if this expansion, this eternal drift, is not the last word? What if something shifts? A change not in matter, but in behavior. A quiet turn in the rhythm of expansion. You reach toward that question, tentative, curious. Because even in this silence, there is the possibility of something more. What if it turns? Asterisk, asterisk, you linger now at the far reaches of time, where space is wide, and silence feels eternal. All around you is stillness, not because there is nothing, but because everything is too far apart to speak. But somewhere in that silence, a question stirs. What if the stretch stops? What if dark energy, this subtle push woven into the bones of space, is not eternal? What if it is a passing phase? You float beside this thought, like drifting near the shadow of a wave. It is not loud, but it changes everything. Because if dark energy fades, the universe will not continue to drift into a colder and colder loneliness. If it changes direction even slightly, the expansion could slow, then pause, and one day begin to reverse. This idea is known as the Big Crunch, a speculative, whispered mirror of the Big Bang. Instead of expanding forever, the universe might turn inward, curving back on itself like breath returning to the lungs. Galaxies now drifting apart would slow in their retreat. The light now redshifting outward would begin to slide back into higher, bluer energies. Gravity, quiet for so long, would awaken. You feel it now, the balance shifting. It begins with tiny decelerations, barely noticeable. Distances grow more slowly. The dark energy term in the equation weakens, its value falling not to zero, but changing character. And then the stretching stops. You imagine standing between galaxies as the distance holds still, for the first time in countless trillions of years. A moment of cosmic breathlessness. Then the reversal begins. The space between clusters contracts. Galaxies begin to edge closer, not drawn by strings, but carried by the fold of space itself. The stars that once vanished beyond the horizon begin to return. Not quickly, not all at once, but the universe is no longer drifting outward, it is curling inward. You drift through this future, feeling how gravity gains strength again, not because it changed, but because distance no longer favors the stretch. The cosmic microwave background, the oldest light in the universe, brightens, warms, not because new light is made, but because all light is moving again through space that is compressing. The cooling ends. The silence tightens. Matter meets matter again. You imagine galaxies colliding not as chaos, but as reunion. The great structures of the cosmos folding back together, like a hand closing into a fist. Stars form again from gas drawn inward. Old black holes converge. The sky fills with activity, not like the first time, but with a different rhythm, a last blooming. And then, in this speculative future, everything contracts. Light blue shifts, distances shrink, space folds, and eventually, the matter of the universe collapses back toward a single point, dense and hot, where time begins to curve in on itself. A singularity not unlike the one that began it all. Could this be the end? Or the start of something new? Could the universe begin again, reborn in its own ashes? Another Big Bang, from the embers of a final collapse? You rest in this question. It is not answerable. Not yet, perhaps not ever. But the idea that dark energy could turn, that the arrow of expansion is not fixed, invites wonder. Because we do not yet know what dark energy is. It may be a constant, written into the laws of spacetime. Or it may be a field, like an ocean beneath the universe, whose pressure and flow change with time. Some call it quintessence, a dynamic energy, slower than light, shifting like wind beneath the stars. If dark energy is such a field, it may fade, rise, oscillate, or die. It may grow stronger and tear the universe apart. Or it may reverse and lead us back to the beginning. Each possibility is shaped not by dreams, but by math, by observation, by the quiet hum of data that still whispers through our telescopes. You drift once more beside those instruments, those human eyes extended into the dark, asking not only what is happening, but what could happen next. Because the fate of everything depends on the smallest details of something we cannot see. And now, as you hover between endless expansion and slow reversal, you realize something tender. We do not know how this ends. And that is part of the beauty. The universe is not only a place, it is a question. And we are part of how it asks itself what it might become. So you drift forward once more, into the space between possibilities, carried not by certainty, but by wonder. And as you turn your gaze to one final possibility, a universe that tears itself apart not slowly, but suddenly, you wonder, what if dark energy doesn't fade, but grows stronger? The tearing of everything ***, you have floated through cold endings, through soft silences, through imagined reversals. But now, a sharper possibility rises like a ripple through thought. What if dark energy does not weaken or slow? What if it grows stronger? Not just steady and quiet, but increasing with time. This idea carries a different kind of weight. Not the hush of drift, but the tension of unraveling. Physicists have given it a name, the Big Rip. You drift toward that idea as if moving into a wind that grows with every step. It begins gently, just like before. Galaxies move apart, the fabric of space stretches, but faster now. Faster than gravity can hold. Faster than light can bridge. Faster than matter can bear. Dark energy, in this version, is not constant. It strengthens. Its pressure increases. Its stretching grows not linearly, but exponentially. You hover in a universe ruled by this fierce expansion. It looks familiar, but feels unstable. The laws still apply, but they strain. The bonds between things begin to loosen, not just between galaxies, but within them. First, the clusters lose one another. Then the galaxies inside the clusters begin to pull apart. You feel it happening, not like a shove, but like threads losing tension. Gravity, once the quiet architect, cannot keep pace. Galaxies, those grand spirals of stars, become undone. Their orbits no longer hold. Stars begin to wander, flung outward not by force, but by space itself slipping out beneath them. It is not explosive. It is not sudden. But it is unstoppable. The Milky Way begins to thin. Solar systems unravel. Planets slip from their stars, not because they are pushed, but because the distances within them grow. Now you feel it more closely. You pass through a future Earth where gravity no longer binds things with confidence. Tides shift. Orbits wobble. The atmosphere trembles. Even molecules begin to drift. The expansion has reached the scale of planets, of atoms. The dark energy, now ferocious, pulls space itself faster than the bonds that hold matter together can resist. You try to hold a thought, but even that becomes difficult, as the idea of closeness begins to lose meaning. Electrons no longer circle nuclei. Atoms stretch. Matter softens into silence, not from heat, but from the sheer widening of all that once held. This is the final stage, when the Big Rip moves from galaxies to stars to planets to you. Time before this moment still exists. You rewind briefly. In such a model, the end comes not in trillions of years, but in a finite future, perhaps billions, perhaps sooner, depending on the nature of dark energy's growth. Physicists call this form of energy phantom energy, A dark energy so strong it doesn't just fill space, it accelerates its own growth. In their equations, they find a moment called the rip time, when expansion becomes infinite in finite time. You return to that moment now, hovering just before it. The universe is bright, but trembling. Not from cold, but from overstretch. Every structure that once stood has unraveled. Every bond has broken. Space is no longer a stage. It is a tearing skin, rushing outward faster than meaning can keep up. And then nothing. Not collapse. Not silence. Not cold. But an end to the structures that once allowed anything to be anything at all. And yet you feel no fear. Because even this, as unimaginable as it is not chaos. It is a possibility. A whisper in the equations, a line of logic that simply asks, what if dark energy is not just constant, but ravenous? This future is no more certain than the others. It depends on the nature of something we still do not understand. So you drift backward out of the rip, through the quiet undoing, past the unraveling stars, into the calmer present, where the expansion is fast, but still gentle. You look again at your own galaxy, your sun, your hands. They remain held together by the quiet glue of gravity, electromagnetism, and time. Nothing is tearing. Not yet. Perhaps not ever. And that, too, is part of the story. We live not in a finished universe, but in one mid-thought. We don't know how the sentence ends. We only know it is being written with every passing second. So you ask, softly now, if the universe can end with a whisper or a breath or a tear, might it also end in a transformation? What if the answer to the mystery of dark energy lies not in collapse or explosion, but in something new? What if it's not an ending at all, but a shift into a different kind of reality? A change in the frame ***, you float in the gentle quiet between all possible endings. The cold drift, the slow return, the final rip. Each one, a different answer to a question we're still learning how to ask. But now, another possibility begins to rise. Not a new fate, a new frame. What if dark energy is not a substance or a pressure or a flaw in our equations, but a sign? A clue hinting that the very way we describe the universe is incomplete? You drift through that thought, light as starlight, weightless in the unknown. For decades, we've tried to understand dark energy as a thing. A measurable force, a constant in Einstein's equations, a field, particle, a pressure in the vacuum. But what if it's not any of those? What if it doesn't come from within the universe, but from the way we're trying to describe it? You imagine space not as a fabric being stretched, but as a shadow cast by something else entirely. Physicists have begun to wonder whether our entire idea of spacetime might be emergent, not fundamental. That is, space and time might not be the basic ingredients of the universe. They may arise, like waves on a deeper sea. You drift now into the realm of emergent gravity. A bold and delicate idea. In this view, gravity itself isn't a force. It's a side effect, a gentle organizing principle that emerges from deeper patterns of energy, entropy, and information. Imagine a forest. You walk among the trees and feel the cool air, the dappled light, the scent of green. But you also know the forest is not a single object. It is made of smaller things, molecules, atoms, cells, light, water. Gravity, in this view, is like the coolness of the forest. Not fundamental, but emergent. And maybe dark energy is, too. Not a new particle or force, but a sign that the structure beneath space is shifting. You hover near a blackboard covered in chalk dust and symbols. A tangle of thermodynamics, holography, and quantum entanglement. One equation stands out. Gravity equals entropy plus information. It's not proven. It's not complete. But it's whispering something profound. What if the expansion of the universe is not caused by energy, but by information rearranging itself at the edges of what we can know? You pass through the concept of the holographic principle, the idea that all the information in a region of space is actually stored on its boundary. Like a hologram, what we experience as three-dimensional might be a projection from a two-dimensional surface we can't directly see. It sounds impossible, feels like a dream, but the math holds, and some scientists now wonder if the universe itself is a hologram. a flickering field whose depth is a kind of illusion, crafted from deeper rules we do not yet grasp. In this picture, dark energy is not a force-filling space. It is the gentle hum of that boundary shifting, a change in the way information arranges itself at the edge of time. You imagine space as a song rising from the instruments of quantum fields, geometry, and something stranger still. Dark energy becomes not the lead voice, but the rhythm section, steady, quiet, essential. And perhaps that rhythm is changing because the underlying melody is transforming. What would that mean? It might mean the universe isn't expanding into something, but unfolding from within. It might mean time itself is not a river, but a pattern repeating, evolving, changing shape. It might mean that asking what dark energy is the wrong question. Maybe the better question is, what is the universe becoming? You feel the comfort of not knowing, the warmth of curiosity without conclusion. We are creatures of a small world, curled in gravity's arms, peering outward with glass and code and patient hearts. We measure, we map, we imagine, we question, and in doing so, we join the universe in its unfolding. Dark energy may not be a thing to find, but a doorway into deeper understanding. A sign that we are only at the beginning of knowing what reality is.